Hi, I am Tom Flaum. I recently posted a series of articles on LinkedIn that talk about the use of semantic video search within media supply chain and media workflows in general, as well as video surveillance workflows. In this presentation, I will pick one of the more technical aspects of semantic video search, namely embeddings, and explain them in more detail. What are embeddings? So embeddings is the term that's being used all through AI discussions. So an embedding is, at its physical level, it's 1,000 numbers, 1,000 floating point numbers that has something to do what is in an image. So let's create an embedding. So let's say we want to create an embedding of an image. Let's say this image that you see on the screen here of a frying pan. And in order to create an embedding, you run it through a model, kind of like GraphQL embedding. So you basically run an inference step on the LLM model, and it creates an embedding. The embedding is, as I said, a vector with 1,000 values. Each individual value does not have a meaning. It is just it's just what the LLM, it takes the input and it says this is what it is, and that's what an embedding vector is. Now, what is this useful for? Well, the cool thing about it is that you also get an embedding vector. You can not only create it from an image, you can also create it from text. And let's, instead of taking this image of a frying pan and create an embedding, I'll just take the text, just the two words, frying pan. I send that into the LLM, and it creates an embedding. Again, this creates a vector of 1,000 values. Now, what's cool about this is that when you use a technology called a cosine similarity check on these two vectors, you will notice that these two vectors are similar. So basically, the image of a frying pan and the text frying pan create something that is similar according to this cosine similarity. And you can use, and you hear the term of multimodal AIs. You can not only use images, you can also use video. That's what I've been doing here. You can also use audio. If somebody says the word frying pan, it will also generate, assuming the model supports it and supports audio, it will also create a vector that is similar to the picture of a frying pan. Let me demonstrate what I'm talking about. This is an application that you can actually download. I have it on GitHub, so you can download it. It's all open source, open parameters. You can run it on your local computer. So basically here, I took a video clip. This is a video of just a travel video. It's 5 minutes long. And I basically did an indexing process on it. I took each of the scenes in the video, like from cut to cut, and I created one of these embeddings for each of the scenes. And I stored this in a database. So for each embedding, I have the time code of the scene that created that embedding. And to do a search, I will basically type up here, let's say the word, I'm going to type in frying pan. As I mentioned earlier, the text frying pan will run through the same model that was used to create the embeddings for the video, or a compatible model really, and it will create an embedding vector. I will then take this embedding vector and search through all the embeddings that were created for this video, and it will list here on the left basically the closest matches. The top one will be the closest match of a scene where the embedding vector of the scene matches the embedding vector of the text frying pan the closest. So let me click on this, and you will see, indeed, you see a picture of a video clip. That's a video clip of a frying pan. So let's try something a little bit more complicated, because you can not only use words, you can also describe things. Let's say a table set up for dinner, something like that. Again, I'm taking this text, table set up for dinner. I'm gonna create an embedding vector. I'm gonna compare it to all the embedding vectors that I created for this video clip and rank them. And this one here is the top choice. And fair enough, you kind of get a picture or a video clip of a table that is set up for dinner. Now let's try something else that's an interesting example. Let's look for sunset. And again, I'm take sunset, take the word, create an embedding vector, search it against all the videos that I have, all the scenes that I have, all the embedding vectors, and let's look at the top hit. The top hit here is this here, and fair enough, it's a picture of a sunset. But let's also look at the second hit here, also a sunset. And as you notice, this is the same picture that I got before or the same scene that I got before when I looked for the dinner table. So the embedding for the word dinner table is similar to this scene, but so is the embedding of the word sunset. So basically, it's not, and this is the power of semantic AI, that there are multiple words that can match closely with a specific scene. Let's go back to the PowerPoint and just explain again what kind of happened here. I took a video, a 5-minute video, and for each scene in this video, I created an embedding vector, and I stored this embedding vector in a database. When I search, I take the text, and I also create an embedding vector, and then I take this embedding vector and compare it to all the embedding vectors that are associated with the video clip, find the one that is closest, rank the closest ones, and then when I click on one of the close matches, I'll basically go into the database and find the corresponding time code and pull that video back and play it. And that is what's happening what's happening in this application. Thank you for watching. I hope this was helpful for explaining the somewhat confusing concept of embeddings. As I said at the beginning, there's more information on how semantic search can be used in media workflows as well as surveillance workflows. And I posted these articles on LinkedIn, so you can go to my LinkedIn homepage and you will find them. You can also find that information on my website, which is tpflconsulting.com. I mentioned that the application that I showed is open source. You can download it from GitHub. And feel free to reach out to me either on LinkedIn or at the email you can see on the screen here. Again, thank you so much for listening.